because we don't have a lot of time. The library's gracious to let us out at 8:35, but we want to keep things moving. We want to give you guys enough time to be able to ask all your questions and have them answered. So if you want to write them down, or if you just want to keep it in your head, we'll hand a microphone out. If you're not shy, you can speak your question aloud, or if you want to pass your index card forward, I'll read it. And then, like I said, at the end, we'll bang them all out. So we're going to get started with the presentations. Our first presentation tonight will be given by Nick Falkenberg. Nick is a licensed professional geologist. He has over 40 years of experience in studying and remediating hazardous waste sites across the nation and Long Island. Much of his work focused on the design of groundwater contamination investigations and remediation projects for Superfund sites. Tonight, Nick will be discussing the nature of naturally occurring radioactive materials on Long Island.
Thank you, Elise, and good evening, everybody. As Elise mentioned, the purpose of tonight's meeting is really to discuss the occurrence of radioactive materials in the groundwater in the vicinity of the Bethpage site. You'll hear several presentations about the specifics of the concentrations of radium concentrations that were found in the groundwater. Mike Hauptman, who will follow me immediately, will get into some detail on that subject. But I would like to spend the next 10 minutes just giving you some information about the occurrence of naturally occurring radioactive material, which is exclusively dependent on the geology of our area. Generally, radioactive elements have always been present in the Earth crust. As you may know, an element is really a basic building material. There is no way to physically change an element. You remember centuries ago, people tried to convert iron into gold or silver, and of course that never worked. The only way that an element can transform itself is actually through radioactive decay. And in our particular case here, the source materials for the geologic layers we have beneath us contain the element uranium, which decays to radium, which decays to these radioactive materials in groundwater are not detectable with your senses. You can't smell them, you can't taste them, you can't feel them. So if they're there, the only way to determine that is with a sampling program or some sort of a radioactive particles measuring device. Long Island's aquifer system, as I mentioned, is really dependent on the geology. We have two main aquifers on the island. One is called the Upper Glacial Aquifer, which I'll discuss in a minute, but the main one is the Magathie Aquifer, which lies below it. There is another important aquifer called the Lloyd Aquifer below a clay layer, but for our purposes, it's the Upper Glacial Aquifer and the Magathie Aquifer that are of interest to us because there are very few wells in the Lloyd Aquifer itself. Just based on an examination of the geology of the site, we know that low levels of radioactive material occur, and so do their decay products. whenever you collect a sample of groundwater, you will see these materials. Hopefully the concentrations are low, and as you'll see in a minute, the U.S. Environmental Protection Agency has set a drinking water standard for most of them. Not only that, but the US EPA has set a standard for radon gas, which, as I mentioned before, is a decay product of radium of 2 picocuries per liter in the air. So what happens in many cases is where radon is suspected, you can analyze an air sample in the basement. If the concentration is above 2 picocuries per liter, then the EPA recommends that something should be done about it. In areas where the geology consists mainly of granite, where concentrations of uranium are higher than in other rocks for some reason. I'm not sure exactly the geologic explanation for that, but in those areas, concentrations of radium in the groundwater can be high, and the concentrations of radon can actually be significant. Just to show you, or give you an idea of Long Island's surface geology, we are sitting on a thick deposit of what are called glacial deposits. And what this slide shows is the Laurentide ice sheet that existed about 10,000 years ago. At its height, it was something like 200 feet thick. And it acted as a huge bulldozer, scraping rocks and material off the Canadian Shield and upstate New York, pushed it all the way down to the New York area, and then as it melted, it dumped all this material here. So what you've ended up with is a terminal moraine here. This is Long Island. But to a large extent, the material that was scraped off the Canadian Shield and from upstate New York dictates the concentration of these radioactive materials in the groundwater. With respect to radon, this map shows where high radon concentrations might be expected. You can look at the purple area where concentrations, I think, are above 4 picocuries per liter, but you can see, if you look at Long Island, you can see that it's in the yellow area, and in general, concentrations of radon should be below 2 picocuries per liter. In April 2018, the Navy conducted a radium level study and concluded that the concentrations of radium in the groundwater were consistent with naturally occurring levels. The data that we've looked at gives us some concern that that may not necessarily be correct, and that's the reason why we have requested a large, comprehensive study of the radium in the groundwater and other radioactive materials. As you'll see a little bit later on, there are areas where the concentrations of radium look like they're way above where they should be. That is low levels. And the evidence that the Navy has for concluding that these levels are natural is, I think, a little bit inconclusive. They relied heavily on a report done by the U.S. Geological Survey that collected a larger number of samples, 1,270 in the Atlantic coastal plain aquifer, which extends all the way from Long Island down to Virginia. And anyway, it covers, I think, a 50,000 square mile area in 6 states. But the important thing I want you to remember is that not a single sample was collected on Long Island. So how they can conclude that a study like this is representative of a Superfund site on Long Island, I think, is a little difficult to understand. This is simply a map showing the sampling locations. It's hard to see, but if you look carefully, Long Island is right here. And if you look very carefully, you can see there's not a single circle on Long Island. That's how we came to the conclusion that there were no samples collected at all. Okay, so in order to determine what natural levels of radium are present in the groundwater on Long Island, we looked at samples, a large number of samples that were collected from 4 water district wells. And we think that these data are actually representative of natural levels. And this slide shows the breakout of the concentrations. For example, if you look at the Hicksville Water District, samples were collected from the years 2013 to 2017. The concentrations of radium ranged from 0.76 to 3.44 picocuries per liter. You can look down to South Farmingdale, Plainview, and Massapequa, and you'll see that the concentrations are equally low. There was no sample where the radium concentration was above the drinking water standard of 5 picocuries per liter. And as you'll see in a minute, concentrations of radium downgrading to the Bethpage site and at some locations were above the MCL, and that gave us some concerns. This slide shows 2 maps. If you look at the one on the left, there are red circles, blue circles, and the concentrations of radium in wells shown on the red dots are below the MCL, below the drinking water standard, and by the way, MCL stands for maximum contaminant level. The blue dots represent locations where the concentrations were above the drinking water standard. And if you look at this map, the groundwater flow direction is to the southeast. The blue area is the Northrop Grumman site, and you can see virtually all the samples that were collected with concentrations above the MCL are in the direction of groundwater flow away from the Northrop Grumman site, which is what you might expect if the source existed on the site itself. The slide on the right just simply shows a little clearer where the wells that had concentrations above the MCL were collected. Those are the blue dots, and the 2 green dots here represent the 2 buildings on the property where radioactive materials were used at one point. Okay, so I just want to sum up quickly. The maximum contaminant level set by the DEC for radium 228 and 226 combined is 5 picocuries per liter. The Bethpage Water District is in this area, but it's the only area where a public supply well has ever been shut down because concentrations of radium were above the maximum contaminant level. And as I mentioned before, the one well that was shut down was down gradient or in the direction of groundwater flow away from the Northrop Grumman site. There are several monitoring wells where the concentrations are also above the MCL. Mike Hauptman will discuss that in more detail. And based on the data we've looked at, it's not possible, I think, to determine whether or not these higher levels of radium above the maximum contaminant level are really natural or not. There's some questions about how the samples were collected, when they were collected, and so on. So that is why we have simply requested in our lawsuit that the court authorized us to do a large comprehensive study of radium in the groundwater so that we can determine whether the concentrations of radium are really natural or whether they are man-made. If they're man-made, they will have to be investigated and potentially cleaned up. Thank you.
Thank you, Nick. All right, our next presentation will be by Mike Hauptman. Mike is a licensed professional engineer. He has over 30 years of experience in environmental remediation. He was a remediation design and construction engineer at Brookhaven National Labs, where he was responsible for the remediation of, among other things, radionuclides in the groundwater and in soil. Tonight, Mike will be discussing the radioactive materials that have been detected specifically in Bethpage. So everyone give it up for Mike.
Thank you everybody. It's a pleasure to be here tonight. Thank you Elise for that lovely introduction. Move forward. There we go. Okay, this is what I would like to talk about is what's the evidence that, I mean, you've got an indication that we are coming at this a little differently from the Navy and from the government. So what's the evidence that we see that makes us believe that there is something else going on here than what you've heard from other folks? So I'm going to talk about the, well, very quickly, about the radium in my supply well. I'm going to talk about the Plume map that you just saw. I'm going to talk about detections in groundwater. And I'm going to talk a little bit about the detections at the Bethpage School District monitoring wells. And then I'm going to touch on the Navy's latest report from 2018, where they came to a conclusion that these were all naturally occurring radionuclides. And then I'm going to touch a little bit just on radon as well. So first, let's talk about that supply well again. So in 2013, the water district started seeing elevated concentrations in the supply well, and they said, okay, later on, with the well shut down, the concentrations in that supply well did exceed 5 picocuries per liter, which is the drinking water standard, as Nick said. And it's been shut down ever since, and it is the only supply well on Long Island, certainly, that has ever been shut down for radionuclides. And go back to the next. This Plume map. Occurred in recent years of sampling are down gradient from the plume. So again, these are potential source areas. Building 10 was one, which is where radium could have been used by the Navy in the manufacture of the warplanes and other instrumentation. And so that could be the source of the radium. And the Bethpage supply well here is number 6 that was shut down. So again, it's right within the flow path of the Plume. And these are the Bethpage School District wells, which I'm going to talk about, or locations where they have wells. I'm going to talk about in a second. Why would the radium be traveling slower than So let's see, I think I reviewed most of this. 16 wells had those higher concentrations. And the important thing to remember is that this suggests a potential source of radium at Bethpage facility. So north to the south, and to the north, east, and west, no detections, down gradient with the groundwater flow, detections grade up to over 8 picocuries per liter detections. Just a little bit about I showed you those 3 yellow circles, those are the school districts. You'll notice that these are relatively high. The highest in the monitoring wells was a little over 8 picocuries per liter. These are greater than that, and as far as we're concerned, right now this just shows that there could be something there. We don't know exactly how these samples were collected and treated before they're analyzed in the laboratories. So we don't know in particular if these were filtered. So this could be a lot of aquifer materials that's mixed in, and that would confound the results. But I did want to show this to you that there were detections in the Bethpage monitoring wells at the schools. So let me go on to the Navy's report for a second. So they did an in-depth study, and I want to focus on the conclusions that they, as I said, we differ in our interpretation of looking at the data. The Navy did acknowledge that there were concentrations greater than the drinking water standard south of the Plume, but they said there's no pattern. Where we see a pattern, they did not, and the reason they didn't see a pattern, they specifically said, is because there are depth differences. So the aquifer is several hundred feet thick. Some of the data is in the upper 100 feet, and some of it ranges down to, say, 300 feet below land surface. That is another interpretation. However, you wouldn't expect that if there was just a transport from the source, because it's smooth flow normally. Groundwater flows smoothly. There's no turbulence in it. So you wouldn't expect those